Hi, welcome to what's going to be a series of quick 5-minute videos on principles of mechanical engineering for Cambridge Technical Unit 3 examination. So you can do these quite easily. If you want to practice a bending moment diagram, just grab a ruler, work to a scale. I'm going to do 5 centimeters, so that's going to be 5 meters, and I'm going to create 2 loads, so one at 3 and one at 4. So I've got 3 meters, 1 meter, 1 meter. Now I've got A and B. I'm going to be looking to calculate a reaction at A and a reaction at B. And for this one I want to look at 2 loads. Downward load, so call it 20 newtons, and an upward load, let's say 10 newtons. It doesn't matter, these will always work out if you just follow this 3-step system. So let's have a quick look. Vertical forces, the sum of the vertical forces is equal to 0. So what does that mean? It means I've got 20 newtons acting downwards, so step 1, I've got 20 newtons going in that direction, and I've got 10 newtons going in that direction, so I'll take that away, is equal to, so I've got a total of 10 newtons in the downward direction. Okay, so if that beam was to be supported, then there must be 10 newtons acting in that direction, so that would equal 0. Okay, step 2. Calculate the bending moments, force times the distance. Okay, so let's just have a quick look at these. We've got a bending moment is a turning force. So if we start at A and we look at this, and you imagine that this force is acting in that direction. It's pivoting around the point A and it's creating a turning force, a bending moment in that direction. So this is clockwise, so it's a positive, and it's 20 newtons acting over 3 meters. So 20 newtons times 3 meters, 2 3s are 6, that's 0, we have 60 newton meters. Okay, let's look at this 10 newtons. The 10 newtons is acting in upward direction, so that's a counterclockwise, it's opposite this one, and it's acting over 4 meters, so negative 10 newtons multiplied by 4 meters is 40 newton meters. So we've got a total bending moment of 60 minus 40, so I've got 20 newton meters, and that, this is how you calculate RB, that 20 newton of turning moment is shared over the whole beam. It's shared over 5 meters. So the result would be 5 into 20 is 4 newtons. So here I've got 4 newtons acting in an upward direction because of the result, the total of 20 newton meters acting downwards and 10 newton meters acting upwards. So if we've got 0, sum of the vertical forces is 0, we've got 4 newtons acting here, then must be the remainder, 6 newtons, must be here. So everything resolves to 0. 3. RA is equal to total vertical forces minus RB would equal 6 newtons. 10 minus the 4 equals the 6, which is reaction at A. Now I want to turn that into a bending moments diagram, so put the pen away, slide this right down so we can see what we're doing, and then what you do, practice, Okay, we're 5 minutes in, so it's going to be maybe a 10-minute video. Is you drop your vertical lines down to create a graph. Take a 0 point, like so. That's unit 0. I'm going to use the carry load method. So I'm going to start here at 0. So we're going to take 6 newtons as an upward force. I'm going to carry it across these 3 meters. So if I do that, like so, I would have 6 newtons times 3 meters. 3 sixes are 18. So on my graph it would go to 18. Like so. Now if I follow the next step, I'm going to carry that load now all the way across there, but I'm also now picking up this 20 newtons, but it's in the opposite direction. It's pushing down. So I've got 6 newtons times 4 meters, but I'm going to take away the 20 newtons over the 1 meter. So 6 fours are 24. 20 newtons is 1, so 24 take away 20 is going to leave 4. So now on my graph I'm at 4. So we'll be about there somewhere. Now it should get down to 0. And how that's going to happen is this. If we slide up a bit just so you can see what's going on, carry the 6 newtons across that whole distance, we'll end up with 6 newtons times 5 meters. 6 fives are 30. I'm going to take the 20, carry it 2 meters, so we've got 20 times 2 is minus 40, and then we've got an upward force, so again it's a positive. We're going to have 10 newtons times 1 meter, that's how far we carry it, and that's going to be plus 10. So 30 take away 40 is minus 10, plus 10 equals 0. And that would be the shape of our bending moment diagram. And that's a quick introduction, if you will, to a bending moment diagram, similar to something you might encounter for a Cambridge technical examination question. And it's worth just, like I say, you can set these up and randomly practice. So I'm going to put one here for you to have a go at. So let's do 5 meters, at 2 meters, and at 3 meters. I'm going to give you a downward force, 5 newtons, and I'm going to give you an upward force of 10 newtons. And what I want you to do is I want you to pause the video, we've got 2 minutes left of a 10-minute video, so I want to pause, take a couple of minutes, go away, have a go for yourself, and then I'll show you the answer. Okay, so let's have a quick look at your answer then and see how you compare to mine. So we have 5 newtons down, 10 newtons up, so we've got a total, we've got 5 newtons down, 10 newtons up, so we've got an upward force, it's pulling upwards 5 newtons, so we'd need 5 newtons pushing down, so actually the reaction is going to be this way. Okay, so I need a 0 point on our graph. Bending moments. 5 newtons times 2 meters is 10 newton meters. Take away the reaction, 10 newtons over 3 meters is 30, so we end up with a negative minus 20 newton meters in that direction. Divide that by 5 meters. So the reaction at B is 4 newtons pushing downwards. Now the total force, 5 newtons downwards, so we've got 5 newtons, take away 4 newtons is equal to 1 newton. So the reaction at A is 1 newton in that direction. So we've got 1 times the 2 meters, 1 times 2 is 2. Then we've got this point, 1 times 3, and plus 5 times 1. So 1 times 3 is 3, plus the 5 is 8. It's 8. So hopefully this all should resolve. So we have 1 times 5 is 5. We've got the 5 times 3, 3 5s are 15. That's a total of 20. And then we've got 10 in the opposite direction times 2 minus 20 equals 0. So our graph goes back down to 0, like so. So I hope you got something similar, and I hope you find these quick videos really useful. Good luck in the exam.